Hello, everybody. My name is Asante, and today we'll be discussing black holes. In the first pa- in the first part of the lab, we had to find the mass of a black hole, for which the star, which is the yellow body over here, was orbiting around. So here is the code I used for that, where I calculated the net forces and the change in velocity and the components perpendicular and parallel of those two quantities. Here I made delta t around a day. I converted it into seconds, obviously. And then I used that and the final velocity to calculate the mass of the black hole using this equation. And then this is the trajectory I got, and these are the values I got for the forces and the mass. In the second part of the lab, we had to calculate the initial speed of a ship for it to take off and land on a planet without crashing and to pass by a black hole. So here is the code I use for that second part. Here delta T is 1, and I transferred the mass from part 1 for the black hole into this line of code. And through trial and error, I estimated the initial speed of the ship and calculated the net forces and used the net forces to calculate the velocities and positions of the ship and planet. The magenta path represents the ship's path and the cyan path represents the planet's path. The results, the mass of the black hole came out to be 8.84 times 10 to the 33 kilograms. And the initial velocity of the ship turned out to be 100 meters per second in components form, as you can see here. Conclusions, the change of momentum is parallel. The magnitude of the change in momentum is parallel to body motion. However, the change in direction is perpendicular. So it's mainly the net force that causes that change in direction. So obviously you can deduce that the net force is completely perpendicular to the motion of the body. In terms of this simulation, the rate of change seems to be the change in momentum along a period of time. And net force can be defined as a combination of all the forces acting on the body and changing its motion. So what if we decide to enter into an orbit around the black hole? We would probably need a lower velocity because as the ship gets closer to the black hole, the gravitational force from the black hole to the ship is stronger. So the black hole attracts the ship with a stronger velocity, with a stronger force. That's it for today. Thank you for your time.